Commvault Cyber Resilience on AWS, the ultimate protection for your cloud-native workloads. Innovate with confidence knowing that your critical AWS workloads are secure and recoverable. Our industry-leading solution can help you protect your data regardless of whether you're managing a hybrid environment or leading a fully digital native strategy. Experience the peace of mind that comes with comprehensive data protection. Choose Commvault Cyber Resilience on AWS for any workload, anywhere. I'm staff writer Sylvia Oakland, and I'm here at the AWS Summit in Washington, D.C. with Chris Ritter from the Idaho National Lab. Chris, thank you so much for being here with me today.
Thanks for having me, Sylvia.
I'm really excited. So the first thing that I want to do is have you introduce yourself and what you do at the National Lab.
Yeah, that's a great question. So I'm the division director of scientific computing and AI at the National Lab. At INL, our mission is, we're the nation's lead nuclear energy laboratory. So a lot of our research either is in nuclear energy or how to produce critical infrastructure protection for the grid. And so when it comes to nuclear energy, there's a lot of really cool use cases in AI that we're focused on researching. Everything from accelerating deployment of reactors faster to realizing science faster. So think about new fuels and new materials that we can qualify. And then kind of the third area, which may be the most obvious, right, is getting to more autonomy and reactor operations. So as I mentioned to you aside, this organization is relatively new. We've been around for 7 or 8 months. We're a conglomerate of different computing organizations that were already present at INL, and we've kind of brought them all together under one roof, if you will, even though we were actually all in the same building before this, to be able to kind of solve these really big grand challenge problems. Sometimes I call the nuclear problems gold problems, right? Because they're very challenging grand challenge problems that aren't going to be solved with, one more iteration of a large language model. It requires a mix of different computational technologies, not just generative AI, to solve them.
Yeah, and we've heard, especially from previous events and just in some of the press that's been coming out, the Energy Department really wants to lead in both AI and in nuclear. We were both at the Special Competitive Studies Project AI Expo, and that was, one of the main focuses between your counterparts at other labs, and even when Secretary Wright was giving his fireside chat. And so talking about leading the AI revolution, essentially, the national labs have been really working on bolstering that AI workforce and hosting those AI jams. And I loved your joke earlier about jams not being marmalade or huckleberry. But do you mind kind of walking through those 2 AI jams and what that means for the workforce at the national labs?
Yeah, absolutely. So I was just talking about earlier, I think most of my career has been pushing people to adopt the latest technology. There's a really cool new tool, you should try it. And sometimes it can take years, right, to get those tools deployed widely, right, across an organization. Cloud computing, which you and I were talking about earlier, right? Cloud, we've been on I feel like a relatively long journey, right? AWS, that we're at their summit right now, right, started in 2006, if memory serves correct, or in about in that time period. And I still remember, I was a very early adopter of cloud, right? We were deploying it back in the kind of 2008, 2009 era. But it took a long time, right, for government especially, right, to get on board, do their ATOs. When you think of the National Lab System itself, I think many labs got sometimes their first ATO maybe in the last 5 to 7 years. So there was a pretty long gap there, right, for adoption. With generative AI, the point of these AI jams was to get interest from all levels of the organization. So we did a 1,000 scientist AI jam that was across many labs. We were one of the host labs. And what we did was we said, hey, anybody who would like to use the latest generative AI model, we're going to give you, in this particular case, it was most of a day, to use that model in partnership. In our case, we had OpenAI on site. And so we had OpenAI present with our researchers to kind of teach them the absolute latest and greatest models. So for at least half the room, this was their first experience, not with the generative AI model. Everyone has probably used ChatGPT, but their first experience with the latest and greatest models, and their first experience in some cases with a reasoning engine. So that, I think, really got our people behind kind of, wow, this is great technology, and I need this to do my research. And then we also did an AI jam for the lab directors. So there are 17 national lab directors most of them participated actually at SESP's offices in an AI jam. And so that AI jam, the idea was to get them exposed to many different models from most of these hyperscalers we talk about, right? Google, Anthropic, Amazon itself's Nova model, and of course OpenAI. And so we exposed the lab directors of those models. So now we're getting this kind of pull effect, if you will, from both our individual scientists. In fact, as we are sitting here, I'm getting a text from one of our researchers saying, "When can I get this model?" So we have this huge pull coming from the researchers themselves, and we have a pull from the lab directors. So while I feel like always pushing for the latest and greatest technology to be pushed out, we are getting this great pull effect as well from all sides of our organization. We're also having industry pull the labs as well in a way I've never seen before, where I think our use cases, Sam Altman said this publicly, like what
Mhm.
excites him most about AI is like AI for science. And I think it's because our problems are really hard to solve. And there's a huge, huge opportunity. Honestly, some of the greatest things we want to do as a society, right? For our laboratory, right, we're talking about nuclear energy and nuclear power, are the national lab mission spaces. And so if we can use AI to accelerate those missions, you're talking about very world changing technology that everyone can benefit from.
Yeah, I mean, I like to think of it almost as like science powering science, right? Just because of like, you think about how something as mechanical and like very numbers based can be used to help fuel drug discovery. That is like, I cover the health and civilian sector, and that is the biggest thing that I'm hearing right now, is especially with the FDA's recent release of their agency-wide generative AI. Like, that is kind of the first step, into getting AI in the manufacturing process and the approval process. So I think that leads right into like the AI applications that you and your team are using kind of on the back end. But I'd also like to talk about how, like, what you're researching to use AI for within the labs.
Yeah, 100%. So on the back end, we have a tool called Ava, which is an OpenAI based model that is deployed within our security enclave. So that allows our not just researchers but our operations staff to use AI for business needs. So a lot of the use, right, is automating a lot of text generation kind of activities that we're seeing with those models. And it's used by hundreds of, I think, thousands of people at the laboratory as a whole. The second thing that we're seeing though too is code generation. So we talked a little bit offline about our high performance computing infrastructure. Our HPC team deployed some code generation models to HPC, and we kind of thought, well, let's see how many people use it. A couple hundred people picked it up almost right away. So that's that kind of new pull effect from the research staff, where we deploy new models. We're seeing almost immediate use of those models. Same thing with Ava. We didn't do a huge push internally with the lab. We're able to use it. People just organically know that this is a technology that can help them with their job. So those are kind of two examples. Of course, we're always deploying more industry models and making them available to our staff at the laboratory as a whole. Maybe one real world example on a personal note. I use generative AI to solve a real problem that we had that would typically have taken a few weeks. Obviously, it took 2 hours, right, to generate the code. It took more time to verify the code by the team. They took 2 days to look it through with the code than it did to actually generate the code. And so we're seeing a huge kind of push on the coding side. I think being a scientific computing and AI director, right, code is a lot of what we do. And models like Claude are really good at software development. And so I think we're seeing these models getting a lot of organic use, and I think we'll continue to see that increase at the lab. So on the research side, that's one example, right, is using these models to generate code. But on the actual applications, the big problems we talked about earlier, using it to generate CAD models and kind of work through that process. We're also seeing nuclear codes, so nuclear licensing, I should say.
Mm-hmm.
So Microsoft has a tool that they've built that does uses a customized large language model for licensing. So we're seeing companies like Microsoft build these tools, and then of course we're seeing the laboratories look at how can we use these tools to accelerate the licensing process for nuclear reactors. There's a lot of work that is looking at those activities and those kind of areas as part of the process. So to me, it all has to be connected though. So when you think about nuclear licensing and the licensing process, yes, it's generating documents, but it's also, you need to have a full understanding of the engineering life cycle, right? So you need to have kind of this concept of at least semi-autonomous design and autonomous licensing linked together as part of a cohesive ecosystem. And so I think we're at the very early days of that type of technology. Um, the second part is the concept of autonomous labs. So many of our national labs, right, will talk about the idea that we can operate these labs with much more acceleration. So, what does that really mean? So that means using robotics in the laboratory. That means we already have robotics today. So that also means controlling those robotics with AI, taking tasks that would typically take a human 3 times longer and automating them with robotics. Also, at some point, getting to the future where those labs could operate more 24/7. Right now, we, of course, I always say humans like to sleep and eat. And so those labs are getting maybe 10 hours of use a day during the 4 to 5 days that they're being used per week. If we can have those labs operate more autonomously, we could get closer to a 24/7 use. And so why is that important? Anything we can do to push new fuels and materials out for nuclear reactors makes a huge difference for a lot of these startup companies that you're well aware of in the nuclear space. So that's a area that, of course, we're very interested in our domain. You'll also see, to speak more broadly and represent the system, there are other applications for advanced manufacturing. There are applications for biomedical science. Our laboratory doesn't focus on those areas. We do a little bit of advanced manufacturing, but on the biology side and that area, right, we're seeing that's kind of the science laboratories that are leading that mission. But we're all working together, kind of think about how we can solve that problem. And then the third use case, and the one where we've made probably the most strides that are well known publicly, is microreactors. So microreactors are much smaller than, if you have a nuclear reactor near you, you're probably thinking, wow, these are massive machines, and they are very big at the gigawatt scale. But there are also microreactors, right, that operate more on the size of like a car. They're truck shippable or plane shippable. So those reactors can operate for defense applications, right, as they're needed at different sites. They can operate in remote communities like Alaska. And those machines, typically speaking, by rule, they need 3 to 5 operators across 4 different teams. So if you do the quick math in your head, right, that's 16-ish people that need to be available, right? It's not because 60 people are operating the plant at any given point in time. It's because you need 60 people available to operate it 24 hours a day. So what does the future look like? It looks like, in my opinion, personally, it looks like you have a remote operator group that is managing a fleet of these. To do that, unless you want them to be really close to the site, you need some level of autonomy as well. Mm-hmm. So remote operations paired with autonomy, I think, is what the future looks like for microreactors. And so we've been making a lot of strides on autonomy there. So we did our first non-nuclear microreactor test. So what does that mean? It's a heat pipe in an enclosure. And then we streamed the data off that heat pipe in real time, and then used a forecast to kind of predict 10 minutes in the future how that heat pipe would operate, and then control based on that forecast. This is a one-shot problem. We got to do it one time, and it was 0.3% off. So the team did a great job in that first autonomy demonstration 3 years ago. And that was very early technology, right? What we should, always reveal with these things is when we did that, right, we were still passing some CSVs around. All this was being done automatically, but there were, the data architecture was still in the early days. Our machine learning architecture, right, this predates generative AI, was also in the early days. And a lot of our first principles models, while we were building them at that stage, weren't even ready, right? So we were doing a purely data-driven statistical model to do that forecast. If we fast forward a couple of years later, we did the first digital twin of a reactor last year. So that's the AGN 201. These are 5 watts of power. So very small from a power level, but still from a physical size perspective, right? They're a lot bigger than you might think. Mm-hmm. You might be able to get your arms around it if you stretch them really far. So anyway, so those are university reactors. In our particular case at Idaho State University, they were going to put them around high schools all around the country. So they're very safe. Some people call them zero power reactors, although they're not quite zero power. And so the idea was, could we use an older reactor that's about 50 years old, digitize that reactor, stream it to the cloud in real time, and then use that data to then predict what was being done with that reactor at that point in time accurately, and do that without having any other information other than what's coming directly off the reactor data acquisition system, and doing that near real time, right? Doing that within a minute or two. So the short story is it worked. The long story is there were multiple machine learning models that were running on that facility at all given times. One that was a first principles, which means physics based, right? Think back to those physics equations we all learned in high school or college. And then one that is based on one that's a machine learning model that's based on just the data. So both models were performed really well. We found out in combination is kind of the best kind of output, right? We're able to get the best accuracy having multiple models, which probably makes intuitive sense, but it's something we've been able to prove scientifically that gives us the best rewards. So we did not do control of that reactor because that gets into, if you're familiar with the Nuclear Regulatory Commission, that gets into a different licensing space. Of course, our long-term goal is to prove control as well using that data, but by being able to accurately predict how that reactor is operating, what's happening, these are the science questions that need to be answered now.
Right.
And telling the operator, right, we're giving them decisions, right, that then they can make based on that output. So those decisions can be given in real time. And the way we validated this was with a red-blue team test, where the red team, what they were doing with the reactor was unknown to the blue team with what was being done. So the blue team had to prove that what they discovered was correct back to the red team. And you're probably like, oh, they had like a week to prepare that presentation. We gave them 30 minutes.
Wow.
So that basically it forces the AI to make all those decisions. And then the humans are just presenting what the AI found.
That's incredible. I think, and correct me if I'm wrong, really figuring out how to use AI both to like speed up those permitting processes, but using it also in like the lab itself. I know you talked about during your panel the fact that people in HR are the ones who seem to be driving some of this need and want for AI applications, these AI tools right in their hands.
Yeah, I think we're seeing almost every organization across the lab complex pushing for AI use. And it's a great thing to see, right? I think, of course, every use is different. I think what I was trying to use in the panel as an example was our accounting teams, our financial teams are really pushing for, how can we build customized applications that leverage our unique data that we have combined with an LLM to do forecasting in real time, to be able to answer questions faster to their customers, who ironically are usually the researchers, and to also make sure that they're being more efficient and answering the need across the laboratory complex. But we're seeing that with HR. There are people particularly in our training organization, right, that are looking at AI use and how that can affect being more efficient with training applications. On a broad sense, right, communications, journalism, right?
Yeah.
There's definitely a lot of use in large language models, if anything, just to check your work, right? Hey, here's a piece I wrote. Is this accurate? I'm sure in your work too, you're using LLMs to kind of verify, is this, what could I do that would make this stronger? Or is there anything in here that could be inaccurate?
Yeah, definitely using it. And what I heard on that panel, using it for like document summarization, right? There are so many, congressional things that we need to go through, so many, workshops and use cases, and sometimes sifting through all of that, especially word jargon heavy data, is really, really difficult. And I think the last question that I want to leave us with is, what do you see coming next for AI and how it can empower, the government cloud capabilities that we have?
That's another great question. So I think, and I said this publicly, I think we're at the very early days of generative AI. The closest analogy I can think of that is something that we've all gone through is the internet revolution. Some people compare it to the industrial revolution in scale, right? Because the internet, while it definitely changed our lives, it's more maybe comparable to the industrial revolution with the impact it will have long term. And so today, we talk about, probably the most pervasive use of generative AI is being used to generate text and being used to augment that area right now. If you look at most organizations around the country, very few are probably using LLMs, for my example, with accounting and things like that. And I think we're going to see slowly but surely those applications get implemented and more automation occurring. So with that change, I think we need to get the workforce and the students ready for it. I spend quite a bit of time interfacing with even community college leaders in our community of looking at how can we get generative AI to be a pervasive thing that everyone is learning at those layers. My own kids, right? I encourage them to use generative AI. They're at the teenager level, I should say. Obviously, my 3-year-old is not using generative AI models to my knowledge, but she is reading Neural Networks for Babies. But anyways, so I think we really need to prepare our workforce for being AI natives, just like we prepared them in the last generation for being internet natives, right?
Right.
And everyone knows how to use email. Everyone knows how to use the internet to find information. And so I think change will be fast, but maybe not as fast as in every area. But I think it will. If you think about the internet, because I grew up with the internet being new, I think it took quite a while, right? If you think it was like 1996, I think is when a lot of the first web properties kind of first came public. But it wasn't until 2006 that AWS came out, and then it wasn't maybe until 2016 that we saw a lot of federal agencies adopt cloud, which is really what I think the internet brought on as a huge advantage. So that was a 20-year time frame. I don't think we'll see 20 years before generative AI starts to provide more efficiency optimizations across the enterprise. So I think getting ready for making sure we are pushing AI into as many places as possible where it makes sense, and also making sure we verify that the model is working the way we expected, because that's another thing. Being from a any kind of scientific organization, we would tell you that, of course, you need to check and make sure that application, that use of generative AI is actually generating good results and isn't inputting biases and things like that in the data.
Right. I think you provided us with some really great examples of how both government and the national labs are going to adopt AI and these cloud capabilities from a bottom up and a top down, and really making sure that every aspect of a government agency, a research lab, even a community college can use AI to just accelerate what they're already doing and really make some real change in the scientific community. So thank you so much for joining us, and I'm so glad that we were able to talk.
Yeah, thanks so much, Sylvia, for having me.